So let's do an example where we have an integral and we'll use an algebraic check for even and odd functions to see if we can use symmetry on it. And again, symmetry is a powerful concept in mathematics and often leads us to a more efficient way of doing a problem. So the problem at hand is cosine of 2x plus cosine of x sine of x dx. Okay, so the first thing to note is that we are symmetric about the origin because we're going from minus a to a, right? That's the first check. If that's not the case, you can't use any symmetry. Now the next question is, well, is this function this integrand even or odd? So since you are adding pieces, you can look at each piece. We know that cosine is an even function, so I can attack that with 2 times the integral from 0 to pi over 2. But the big question here is, what is cosine x sine x? So let's pull aside and do a check and see what we have here. So we're going to check, and this is a good review so that you know how to check if something is even or odd. So let's check if cosine of x sine of x is even or odd. So let me put out some facts first that we know. And we know that cosine of x is an even function. And by definition of an even function, we know that cosine of negative x is going to equal cosine of x. By definition, right? By definition of an even function. By definition of an even function. That's the case. So next fact that we know is that sine of x is an odd function. And by definition, we know what that means as well. That means that sine of negative x will yield the opposite of sine of x. By definition, right? Because, let me go back here. This is f of negative x should equal f of x. Right? That's the definition of an even function. And for an odd function, we have f of negative x equaling the opposite of f of x. So they're the two facts. Now we're going to look at the product of the two and try and discern whether that's even or odd. So let me just call g of x. Let g of x equal cosine of x sine of x. And we're checking to see if it's even or odd. So in that check, we're going to substitute in negative x. So let's go ahead and do that. G of negative x. So what that resolves to is wherever there is an x, you're going to replace it with a negative x. Well, what do we know? Okay, so on the left-hand side, we still have g of negative x. We know that on the right-hand side, cosine of negative x, by definition, is equal to cosine of x. So I can replace that, and I'm going to. So I'm going to replace that. Grab a different color so you can see it. I'm going to replace that with cosine of x because that is a fact by definition. And I know that sine of negative x is equal to negative sine of x. So I'm going to go ahead and do that. So negative sine of x. Well, I'm going to reorder that a bit so that you can see what happened. I'm going to pull that negative sign out in front, and I have cosine of x because it's multiplied, doesn't matter what order. And I have this. Well, this piece is just g of x. So what I have here is g of negative x is equal to minus g of x. And by definition, that's an odd function. So I've proven algebraically that the multiplication of cosine and sine is odd. Okay? So what does that mean? Well, that's nice because now I can just come back here and say, this is odd. So therefore, that piece is 0. So this integral boils down to a very simplified problem because now, right, well, let me rewrite the whole thing. So now this problem that looked a bit complicated from the start boils down very, very nicely to a simple problem. And again, that's where symmetry helps us out. So this is equal to 0. So I can rewrite this problem as this simple integrand. And we know by formula that what turns out to be quite nice is that the integral of cosine of ax is equal to 1 over a sine of ax. That's just by formula, okay? So that's our antiderivative. So our antiderivative then, once we integrate, we get rid of the sine, is 1/2 sine of 2x. And we're going to evaluate that between 0 and pi over 2. So that's nice because those are going to cancel, and we're just left with sine of 2x. That vertical bar tells you evaluate between 0 and pi over 2. That's your fundamental theorem of calculus, right? So this is equal to sine of 2 times pi over 2, because that's what your x is, minus sine of 2 times 0. Remember, that's your f of b minus your f of a, right, by the fundamental theorem of calculus. So this is nice because what do we know about sine of pi and sine of 0? Well, let's take a look at the sine function so we know how it behaves. We know with sine, right? Here's pi. So at pi, sine of pi is equal to 0. And the sine of 0 is also equal to 0. So the answer here is simply 0. So symmetry helped quite a bit to simplify this. And I think this was a good example for you to differentiate why something's even or odd. And we'll do a little bit of practice in our flip portion of the class.